He is happily married and a proud father, and his work bridges technical expertise with visionary leadership to shape the future of infrastructure in developing economies.
A round of applause for him. Thank you, sir. You have 15 minutes minus 2, Abi.
All right, thank you. Standing on existing protocol, I think the citation should probably be skipped so I can have additional minutes. All right. Okay, I have my slide up. Immersive infrastructure for climate adaptive cities. Integrating BIM, geospatial intelligence, virtual reality for resilient urban futures. I'm coming not to give you a full technical detail or presentation. I'm coming to showcase a demonstration of what the solution that we've been talking about, what it does. Unfortunately today, or let me use the word unfortunately, I will have come with something that is tailored towards flood so that it will be more relatable based on the current incidents we have in Lagos. Next slide, please. Okay. What if we could experience infrastructure before we built it? Right now, Lagos dwellers, people living on the island, are probably experiencing what has been built. But now we are saying, what if you can experience something before it's being built? So that is what we are trying to give to you, that we can design a city, experience the city, predicts all the possible occurrence before it's actually being built. So my presentation today, which is a poster presentation, is centered around immersive design, whereby you experience a design before the construction or before the groundwork kickstarts. So today's most complex engineering challenges demand more than drawings. They demand presence, the ability to step inside the design, understand the spatial relationship, and make decisions with genuine confidence before a single foundation is being laid. So the infrastructure challenge has changed. Yes, global warming is alarming. The climate change is almost something that every year now we get to experience flood. The earlier presenters has identified something, said Abuja has to be a city that was planned, but now in the last couple of weeks we experienced flood in areas we've not even had flood in years. So urban infrastructure must simultaneously respond to the following keys that I like here: climate and flood risk, rapid urbanization. Earlier presenter has told us that in the next couple of years, it is expected that the number of urban dwellers is going to increase massively. So our infrastructure needs to actually respond to that. Increasing traffic demand, complex terrain and land constraints. Wetlands are being converted to real estate, which is not supposed to be. So we are talking about the complex terrain and the land constraint. We have utility and infrastructure conflicts, environmental considerations, construction life cycle costs, and growing stakeholders' expectation. The question is not whether to adopt massive tools, it is how quickly can we integrate, because the way things are changing now, the speed at which design is evolving, the speed at which global warming is happening, we can't but evolve and adapt quickly. We can integrate them into every major infrastructure decision we want to make. So what is immersive infrastructure? It's not different from the normal infrastructure you are used to, your road, your bridge, your hydraulic structures, your culverts, your dams. These are still the same infrastructures, but we are now using the word immersive. How do you immerse yourself as a professional into an infrastructure before it's being built? So immersive infrastructure is not a single technology. It is the deliberate convergence of 4 disciplines into a unified engineering environment. Please take note, an environment is being coded. There's something we call common data environment, which is where most of the professionals, be you urban and regional planner, you're a GIS expert or surveyor, everybody comes together with their own information, and we keep it in this CDE environment, and we can all relate, immerse ourselves into it, and also experience what it's about. Instead of asking stakeholders to mentally translate plans, I can ask some of our young engineers here now what profiles looks like. If I ask you what is a road profile, you probably say, okay, a road profile is just a line that gives me the elevation information and all like that. Well, what if you can actually experience and immerse yourself and understand how a road profile actually works? sections, we allow them to step physically inside the proposed infrastructure. So these are the four pillars that probably put the virtual environment or the massive experience that we have in our infrastructure that makes it the massive infrastructure. Geospatial intelligence, BIM and infrastructure modeling, which is one of the core of my institution, the massive visualization, and then the engineering decision making. The first three is more of the technical part or is more of the technology part whereby you and I put our heads together to do all these things. But if the last one is taken out, then more or less like we're just trying to play around something, the engineering decision making. So the decision has to be made after I put you into a design environment, I put into the virtual world of what is to be constructed, then you can experience it and know that, oh, please, there's possible flooding incident that's going to happen if we build this now. So these are the what's going to be the four pillars, but the core one is the engineering decision that is going to be made at the end of the virtual experience. So here's just the digital workflow for most of the people that have been asking. We capture, we contextualize, we engineer, then we integrate and we visualize. For the capture, there are different technologies that we use. From our own end, we use drones. We rely on GIS information, and then we use a bit of AI now, which is more of very sophisticated and it enhances our workflow. More or less like even closes the timeline that we use in capturing existing data. Somebody asked, Lekki is already existing everywhere. How do we now solve the problem? Yes, one of the things that we can do is to create the existing model of Lekki that has already been built and take it to this virtual world and simulate different flood case scenarios. We can simulate as high as, okay, what if the lagoon go as high as 4 meters? What happens? The tsunami that is coming, let's simulate it. And you'll be inside this virtual world and you see it coming, though you won't die, but in real life, you eventually. So those are the things that the virtual world gives us advantage to see what is coming and then try to avoid it. So we contextualize as the engineering professional, we design it, then we integrate all this together, then we visualize. The objective is not just the virtual reality, the objective is better engineering decisions. Yes, we must have seen taking our children to play all this arcade where they use this VR. It's for fun, but now it's getting into the engineering part to make better engineering decisions. I'm going to get into the demonstration part. We'll see what we have. So a case study, like I said, I wish I was prepared to use a flood case since that's what is prevalent in Lagos, but I have a trumpet interchange design that is a proposed design. So we're going to experience it and then we're going to see how it looks like. So a trumpet interchange serves as a case study today, demonstrating how BIM transform disconnected drawings into a fully coordinated digital infrastructure system. So these are just the process we took to get that into a massive infrastructure. Horizontal alignment and vertical profiles, the main carriage and interchange ramps, merge and divergent zones, super elevation, the earthwork cut and fill, all these things are embedded into the virtual world. So the engineering advantage, you can see what I have on the right side of this slide. So this is just the write-up. This is more or less like showing more context to that. Existing condition, an area imagery, a drone map, or whatever you can capture. And then we go into the 2D design, which is the line works that you probably definitely see. And then you can see the 3D corridor design. That's the model part now. It's going into a 3D model. And then you can see the BIM model design, which looks like the 3D definition of what the design looks like. So I'm going to be leaving my stand in a bit to put on the virtual world so we see what I'm trying to say. So from BIM to virtual reality, infrastructure BIM model, we optimize and materials, the real-time engine, and then the virtual reality environment. So I'm going to go there now. I'm going to step inside the design and then we'll see what it looks like. Okay. So most of us have seen this device. This is just a VR headset. So my team has worked extensively to combine all what you're saying, the 3D models of the road and all like that into the device. So I'm going to put on this device. Permission to remove my cap.
Really, Mike.
So because I'm limited by moving around, so I have to rely on this to move around the design. So if not, I have the longer cable, I will walk around the entire space. You see, I'm going to interact with my designing. So
Sorry, let me take you to the center of the stage.
no, you can't. The cable is not that long.
Yeah, just move forward. This is to see cable. Okay, is it okay that this?
But it has this in.
Can we not this PC?
So can you see the screen now? Have you shared the screen?
Cable.
No, it won't work. This particular one is custom. Yes.
Should I hold it? I can hold it. Okay, you can hold it.
No.
Oops, still right. Excuse me. No, he will hold it. He said he can hold it. So
Is it projected? Can you see it on the screen?
I'll project.
Okay.
You don't need the second.
Oh, yeah. Okay, so right now I'm standing. Can we see what I have on the screen, please? So what you're looking at is what I am looking at. Now, the view I'm on now is more or less like a stakeholder view, whereby I can have Mr. Chairman and other stakeholders in the room to also have this on, and then we'll be discussing this design. You can see the interchange which we are talking about. So I'm going to switch to another view, which is more, you can see now, it looks like I'm standing in the cloud looking. Oh, okay. Apologies. Oh, thank you. So I've been seeing myself only. Okay. So I'm going to do that again. So please, can you see now? Okay. So like I was trying to explain earlier, let me go back. So this is the view that you look at. This is the view you look at when you have several stakeholders and you guys have it on the table. Just like model now, this is not on the table now, we're in the virtual world, and we can easily interact and say, okay, this interchange, we have some building that needs to be demolished, this and that. So if you want to get closer and have closer look, this is another one. You can see if I have a longer cable, I can easily walk. So let me go into the individual view now, whereby I can stand on the road. So I need to dodge this vehicle. So yes, just imagine that that was actually a real time. So okay, imagine that was actually a real time. I think I will need someone to hold the mic for me now so I can. All right. All right, thank you. So I'm limited to using these controls because the design is done. It's just a proposal. So I'm inspecting it now to see if there are anything at all. If the curves satisfy the design, if it doesn't, I can look over this side and tell to see what is happening at the what's it called at the embankment. Is it sufficient? Right now, I can easily say that my embankment are not having chutes. So I'm going to tell my design team, please, there's need for chutes to take the runoff along this side so that this embankment does not erode off. So I'm walking up the ramp to the top of the interchange. So like I said, if I had a longer communication cable, I can, sorry, I was about falling. So I can actually walk around this all, and then that's just like me walking within this design model. So now, see, you can see now, I can easily tell my team that look at something happening here. Why is this lapping? So real time, if it's your drainage, if it's your dam, if it's any of your project at all, you can easily experience this. And then, so I'm almost on the bridge. So you can look up, you can see that it's real. The clouds is there. If it's raining, I can as well give you a night time. Let me switch to night. So this is night. So you can see now I'm standing and I need so this is what we call the immersive infrastructure. You experience the design, you make decisive engineering decision with high level precision. Look, I'm already on the bridge. I can easily look at the other side of the bridge. You can see the piers, you can see the abutment. I don't want to move close because I'm going to fall off if I move close. So let me try that for you to see. But if it's in real time, that's bye-bye. But this is the virtual world. We are experiencing this. So you can see me falling off. Wow. So I'm inspecting the piers. I'm looking up to see underneath the ladder beams and the slab to see if everything is okay. So you can see that this is the world we are going to as professionals, as engineering. Design should go beyond the 2D lines. Design should be what we immerse ourselves into. We feel it, experience it, and we can tell. Now I can bend down and tell that, oh, these curves, I need a battered curve, a curve that is chamfered on the edge. Then I can as well tell that, okay, there should be green in between this area. If you are scared of probably maintenance culture, you can say, okay, they should do an interlocking of a concrete cast. So all these things are what you immerse yourself and then you make informed decision. So this is a presentation for flooding scenarios, for dam scenarios. These are possible for you to do the design and then live it, experience it, and then understand what it looks like when you are making design decisions. So let's go back to the slide. Look, just 1 minute. So I'm back to the real world now. Okay. Thank you. So we stepped into the design and then we see what we have. So why does this matter? Engineers, clients and government, contractors and communities and stakeholders. So you could have imagined that you experience this design. It's something that you make a quicker decision and then you tell that, oh, we are good to go with this. This is the future. From immersive windows to living infrastructure. Today, I've shared with us BIM plus GIS plus VR. The next is digital twin. Many of the presentation Elias has talked about digital twin. And I'm just going to tell us that is the next thing our engineers, design engineers, infrastructure engineers should be looking towards, especially Lagos that is experiencing flood. Let's look at how we can start modeling a digital twin of the Lagos city and then start troubleshooting all these flooding scenarios and our infrastructure challenge. The future is the living infrastructure, which is sustainable, resilient, and then the earlier risk and constraint are understood. The greater opportunity to adopt infrastructure is before problems become physical and they are expensive. One of the questions earlier was from the students, how do we bridge the gap, the cost of these programs, the cost of the software, the cost of the technology, how do we bring? So we'll get to that in another forum, but for now, we should not only design infrastructure to survive tomorrow's climate. We should build a digital environment that will allow us to understand tomorrow's challenge before they arrive. So this is the only way we can build and understand tomorrow's challenge before they arrive. Thank you. Don't just review the infrastructure, step inside it.
Thank you so much. Mr. President, we need 2 days for conference now. What we are getting today. Okay, so the only question we entertain from our past president, engineer, so we can also get one online. Thank you, sir.
Thank you, Engineer Ayeni. I'm fascinated with the model that you use to illustrate the concept and sparking up our imagination towards the trend now in engineering, design, and infrastructure. There's a defect that is rampant in highway design and it's been causing a lot of damages, and I can see it's because you use highway to illustrate your point. Some years ago, around COVID, the overhead bridge between Ogudu and Tollgate, the crossover bridge from Ogudu, if you want to access Ogudu area, you ramp up, you are coming from Ogudu, you make a U, you cross the bridge to enter Ogudu area. There was a trailer with container from the port. The head-on, there was a serious damage. Between Ogbomoso and Ilorin, similar phenomenon happened about 7-8 years ago. The problem is this: there is no consistent headroom between the lower highway and the overhead bridge. No consistent by the designer. And I watch your simulation. How will your simulation bring about this mistake? Thank you. Before it happens.
All right. So the question that is asked is about the vertical clearance you have under the bridge. That is surface of the either the gather beam or this thing under the bridge and the finished floor level of your pavement. In this is one of the most practical thing that will appear around in our model. We call it the vertical clearance. Sometimes you probably be seeing some emblem marker of 9 meters, 6 meters, 8 meters, depending on the one that is obtainable in some.
But it is not adhered to at the loading bay.
Yes.
And nobody enforces the
height, the compliance. So as designers, it is just our own responsibility to design based on, okay, now we have user experience of increasing height, then we can as well raise the height or say, okay, Federal Ministry of Works, we've observed that under the gather beams is being chopped off by excessive trailers that are carrying higher distance. Then let's increase our vertical clearance to 9 meters to 8, because currently now we are between 5, 6, and 7 meters. Yes. The cost, it goes on the, because it has higher PS. An abutment. Okay, thank you, sir.
Don't worry, you can go. Okay, thank you very much. Okay, a brief comment from
Well, thank you, Engineer Alonge, for that insightful presentation. One question cropped up my mind while we were doing the presentation. How do we integrate these immersive models into living infrastructure? You know, as a general phenomenon, I know maybe, you are an expert at that today, but for this thing to be very, very effective amongst engineers and designers, do you have a kind of training facility, you know, for this task, or you are just holding on to it, you know, by yourself? Thank you.
That is a good question, sir. And I'm very sure few people in this forum will understand that the organization I stand for, CitiBIM, we have been doing this for the past couple of years, driving this technology adoption, not just using it. We are doing our best to make sure that people, their awareness, number one, then we are training more of the young professionals. On our team now, we have IT students, we have graduate engineers that we are developing on all these technologies, because we need the acceptance, we need the adoption so that this can go round. So yes, at CitiBIM, we do trainings. Even we have a webinar coming up by this weekend where people can actually join and then know what next to do. Thank you, sir.
Thank you, sir. Please, a round of applause for him again. This is very, very, very insightful. Thank you so much, Engineer Alonge. So now we move on to the panel discussion, and this is going to take 20 minutes. Yeah, so it's going to be very, very brief because all has been said, but right now the panel discussion is a very important aspect of our conference. So where we thought together in a conversational manner. And on this panel, we'll have distinguished speakers. Some of them have spoken earlier, and some of them, in fact,